We're going to get started. I want to welcome everyone to the presentation by John H. Graves, Zen and the Art of Counting Fish. The part of the TCBES program is for the graduate students that are in the professional master's track to complete a 600-hour embedded internship with an agency that focuses on the or that works in the field that the graduate student is really excited about contributing to. And that was the really wonderful thing about John, is he came to the program knowing that he wanted to contribute to the greater good. Spent, I would say, only a few weeks trying to figure out exactly what that was, and fell in love with the ocean. And with John and his determination to prepare himself for the career and the life that he wants and the way he wants to be in this world, he worked extremely hard to make this happen for himself. I am so proud of him. And also, I must say, I'm really proud of the journey that took him here, of his background with his BA in anthropology and his BS in biology, and his teaching experience and his lab experience that he had before coming to this program to receive his master's. All, I think, have contributed to his learning journey, but also the learning journey of his peers. He's been, he was a wonderful asset to this cohort and to the cohorts that have come after him and been able to follow his example. It's my pleasure to welcome you all to this talk, and to give a big shout out to John for working so hard and accomplishing so much in such a little time during the past 2 years of this extraordinary experience of being in a global pandemic. He came through, always kept a sense of humor, and kept us all buoyed by it also. So welcome everyone, and welcome John.
All right, mahalo Lisa for that lovely introduction. And thanks to all of you who are here today. I really am so excited to be here, presenting on my journey as I pursued a master's in tropical conservation biology and environmental science here at the University of Hawaii at Hilo. It has been an amazing and fulfilling experience that has altered the trajectory of my life in powerful and positive ways. And yeah, I feel a really deep amount of gratitude for so many people that have helped me along the way. Right, well, let's get going here. One moment. There we go. So the first steps in this program were no walk on the beach. Well, it wasn't only walks on the beach anyhow. And arriving in August of 2020, my first experience of living in Hawaii was in quarantine for 2 weeks. That picture on the bottom left is the first picture that I ever took in Hawaii. And that's from outside the tiny little shack that I lived in on a farmstead on the Hamakua coast, because I couldn't stay in the place I'd signed a lease for the first 2 weeks. Now, the pandemic was strange in a lot of ways. And one of the strangest was that I didn't meet the majority of my peers in my cohort probably for the first year or more of my program. And even though there were aspects of this time period that were really hard, not just for me, but for everybody, it was also a chance to experience Hawaii in a pretty unique way. So the picture on the bottom right is at Makalawena, which is my favorite beach on the face of the planet. And as you can see, there's not another soul there, just me and Finn hanging out. Getting into the incredible natural spaces of this island and feeling that you had this place all to yourself was really a special experience. that I couldn't have had otherwise. And I really am grateful for that. So just a heads up, all the photos here are mine in this presentation, except when they're going to have photo credits from other people. So just so you're aware as we're moving forward. So the coursework in the TCBES program was rigorous and founded in understanding scientific methodology in the context of conservation and ecology. The first semester was brutal, frankly. And during the first 2 weeks of December, during finals, I wasn't sure if I was going to make it in this program. However, adversity breeds resilience, and I am grateful to know that I am capable of sleeping less than 12 hours in a 72-hour period, even if I'd prefer not to repeat that. So more than the bullet points you see in the middle of the screen, the experience of graduate coursework here is probably best summed up by the 3 icons on the right of the screen. You might see some of the other students here today also smiling. For those of you who aren't familiar, the top one is the icon for Lau Lima, which is the online platform, which we conducted all of our coursework on and turned in our assignments. The middle one is the icon for RStudio, which is a statistical analysis and graphical modeling software. And the bottom one is Google Scholar, where many hours are spent pouring through scientific literature. And yeah, these are all indicative of that experience during the pandemic, of us trying to figure it out. And it wasn't just the students either. So hats off to Lisa and all of my professors and mentors who in real time were making this thing work for us and for themselves. So beyond the coursework in the program, I was also honored to serve as the president of the Kaiameaola Club over the past year. Starting out, I honestly didn't really know what to expect, and I was even a little hesitant to take on the role. However, this experience turned out to be formative and deeply positive. Throughout many meetings, email and text chains, planning for club events and community work days, I grew to greatly admire this group of incredibly hardworking and kind humans. In particular, these friendships were forged in the fires of organizing and putting on the Women in STEM, or the Women in Science, and the TCBES Symposium events this past spring, which was a huge commitment of our time and energy. And I have such gratitude for my fellow officers and club members, and I will always be happier for their presence whenever we cross paths in the future. The primary focus of my graduate work revolved around my professional internship with the Division of Aquatic Resources in Kona. The Division of Aquatic Resources, or DAR, is a state agency within the Division of Land and Natural Resources of Hawaii, and they're tasked with managing our nearshore marine and freshwater resources. In Hawaii particularly, coral reefs are fundamentally important as natural resources for recreation, their cultural value, and especially by providing food for many local families. Monitoring reef health and using scientifically grounded approaches in managing these ecosystems is Darkona's greatest responsibility and focus, and by proxy became mine. I fell in love with coral reefs here in Hawaii as soon as I got into the ocean here. These are otherworldly and just incredibly beautiful ecosystems that house an amazing amount of biodiversity here and around the world. Coral reef ecosystems around the world provide refuge, food, and breeding habitat for fully 25% of all known marine species. They are wellsprings of biodiversity. They provide economic value measured in the billions. They are barriers to destructive storms and provide major resources in terms of fish stocks and draws for tourism. But they are under threat. In the Pacific, we've lost about 50% of our live coral cover in just 3 decades. In the Caribbean, that figure is closer to 75%. So this picture here is of a coral colony taken before and after a bleaching event which killed it. And as you can see, the impacts are devastating. The loss of life and also the loss of that habitat that all of these other organisms depend upon is gone when these coral reefs die. Threats to coral reefs are pretty numerous, with bleaching due to anthropogenic climate change being the most existential crisis that they face. They also, especially near places with high population density, face sewage and pollution runoff, nutrient overloading from agricultural runoff, and ocean acidification. This is why it's particularly important to be monitoring these habitats and to know how they're doing as we move forward in the future. So abundant and biodiverse reefs have abundant and biodiverse fish communities. Fish and benthic surveys are able to give us a snapshot of how these ecosystems are doing. And the data provided by these surveys, we can use to measure changes through time in coral health and the reef communities that depend on them. And then using that information, we can inform management and conservation efforts in the future. So my internship was really an act in 3 parts. I got to wear a lot of hats being an intern with DAR, but I'm really going to focus on these 3 main constituents and sort of blocks of time. And these are the Keauhou Bay Sediment Project, the West Hawaii Biodiversity Expedition, which was a research cruise, and a considerable amount of my time and effort was invested in dive training, and then finally getting to get into the field to do these reef surveys. The Keauhou Bay Sediment Project was kind of my first major thing that was assigned to me as a DAR intern. So first, we did sample collection and lab analysis, which I did primarily at the analytical lab where I work here at Hilo, analyzing samples using 5 different methods. The second step I was in charge of entirely, which was statistical analysis, as well as generating figures to visualize these results. And then the final segment of this project was report drafting and editing. And so I co-authored this report with Ashley Pugh of DAR. And so we sort of tackled different sections and then worked together to sort of make it cohesive and then make recommendations at the end. And this project was actually initiated because concerned community members who live by and use this bay for recreation had noticed significant declines in coral over the past decades. And there was real concern that parking lots that had been put in the last decade or so might be increasing the amount of sediment that was running off into this bay. And these concerned community members were raising red flags that these might be one of the reasons corals were dying here. So for the sediment sampling, this was actually conducted by other members of Darkona. And so the samples were collected both in the bay at 3 different sites, as well as terrestrial samples just outside of the bay were collected at 4 sites, with the 2 parking lots being pooled into those 2 sites that are labeled D. You can see there kind of near the top. So marine samples were collected at near shore, mid shore, and far shore, 100 meters apart. And then the terrestrial samples, again, were collected from those 2 parking lot areas, a natural area of basaltic substrate that you would find anywhere in Hawaii, and also from the lawn, which was by the canoe club, just bordering the bay. So once we collected these samples, we had to analyze them. And this was left primarily up to me. So I work for the Hilo Analytical Lab, and we do primarily soil as well as marine sediment sampling, and some other analysis like water quality stuff too. I also have a fair amount of experience as a lab tech previously to moving to Hawaii, working for both Austin Community College, as well as at a couple other places in Texas and Utah. And I was also an intern at 2 different labs one at the University of Texas, and one at Utah State University. So for this analysis, under the tutelage of Steve Colbert with the Marine Science Lab here at Hilo, I analyzed the samples using these first four methods. And these first four methods are loss on ignition, which it's pretty simple. The idea is you take a sample, you heat it up to about 550 degrees Celsius, which burns off all the organic matter, and then you remeasure it at the end. And that gives you a ratio or percentage of how much organic matter is in the sample. The second method is visual microscopy. And this is it's a little bit of a tedious effort where you are literally counting grains of sand into different categories. But it is really useful because it gives you a sense of what the makeup of each sample is. And so it might be broken into groups of that basaltic substrate we talked about, grains of calcium carbonate sand, which come from coral skeletons, olivine, and other things like that. The next method was grain size analysis. And so this is something that I'd never done before, where you take a sediment sample, you pour it through a series of sieves, and each one of the sieves has a finer grain mesh. And you just actually have it like shake for about 20 or 30 minutes. And that separates your sample into these different size classes. And this is really particularly important for marine sediments because this sediment sorting is actually a really good measure of how much wave energy and water current is moving through a system. So things that are really well sorted tend to be in more stable areas with less water energy, and things that are really poorly sorted happen where there's a lot of wave action or water energy. The last analysis that I did personally was the calcium carbonate acidification. So again, calcium carbonate, or CaCO3, is the primary constituent of coral skeletons. So this is actually pretty similar to the loss on ignition analysis, where you do a before and after weight. After you take the initial weight, you acidify the sample, it burns off that calcium carbonate into a gas. And then after you dry it out, you remeasure it, and it gives you a percentage of how much of that coral skeleton, as well as other marine creatures like bivalves, oysters, things like that, that their shells are also made of this calcium carbonate, how much of your sample's composed of that. And then the final set of these analysis was conducted by the Geoarchaeology Lab here at Hilo by Dr. Steve Lundblad. And EDXFR is a form of X-ray fluorescence that allows us to investigate these samples at the elemental and molecular level, so the really, really small scale. And one of the really cool things about EDXRF is that it allows you to pick up on really trace elements that you would not be able to see otherwise. So the next step was entirely on me, and this was the statistical analysis looking at the results from the lab. So we're not going to do a deep dive on any of these analyses, but I do just want to give you sort of a rough sense of what we were finding as we went through this project. So if you look at the top left, this is the figure that I produced from the visible composition microscopy, which is that sorting into different categories. And so if you look at the first three bars, that's the near shore, mid shore, and far shore, you see a pattern emerge, especially with that basaltic rock, which is that black sort of dark gray band there. And as we would expect, near shore, we're seeing a larger percentage of that basaltic rock, which is entering the marine environment from terrestrial sediments, maybe 35% of our sample. Mid shore, we see that decrease to something about 25%. And then far shore, we're seeing that down to about 15%. And again, this is what you would expect in a natural system where you're getting sediment that runs off during storm events, during rainfall, into the natural embayments here in Hawaii and elsewhere. So next up is grain size. And again, this is that measure of sediment sorting, which really tells us, especially in marine sediments, how much wave or water energy is moving through a system. And this one is actually a little more interesting for those first three samples. You can see that both the near shore and the far shore samples had these really low mean grain size, meaning that there were really fine sediments that existed in both of these places. Whereas the sediment sorting in that midshore was actually far less, or there was far less sorting. So what this tells us actually is that in the near shore and the far shore, there's relatively little water energy moving through here, and in the midshore, there's actually more current and wave action happening there. Statistical analysis on the right here. So this is one of our results that came back from the EDXRF analysis from the geoarchaeology lab. And again, this is a really different type of analysis in that it allows us to look at really small trace elements. And so you can see actually here that we're looking at lead and copper measured in parts per million. So these are really, really tiny fractions, right? 80 parts per million, 60 parts per million. But this is exactly what this type of analysis does for us. So you can see actually that same pattern exists for lead and copper in the marine system, where starting at near shore and then moving further and further away, we do see some lead and copper entering the system. And it's also worth noting that lead in particular exists in really, really small amounts in the natural substrate here in Hawaii. And so this tells us that there is some amount of anthropogenic influence or man-made constituents entering the system of water in the bay. So the final part of this was the report drafting. And again, this was co-authored by myself and Ashley Pugh of DAR. And the report was generally divided into the ecological observations, which the DAR Kona team who went and collected the samples observed while they were there, and then into the lab methods and statistical analysis that I did. And then again, we recombined for that final effort on the results and recommendations to move forward. So what we found was that terrestrial soils, of course, are finding their way into Keauhou Bay. And as one would expect in these systems, they're incrementally decreasing the further from shore. The corals that you see in this bay, like the one on the right, there are a lot of corals here who have been killed and undergone mortality in the last decade or so. And you do see a lot of degraded corals. And so the question is, how much is the sedimentation in the bay playing a role here? So one of the things that we looked at too, though, is this picture on the left here is of a relatively healthy coral recruit, which we saw a number of these. And this is telling us that even though sedimentation probably does play a role, that at least some new recruits and some smaller corals are adapted to this environment and do seem to be growing and doing okay. So in 2015 here in Hawaii, and 2016 as well, actually, there was a major bleaching event which took place. And this bleaching event killed corals up and down the Kona coast, as well as on Oahu and other islands in Hawaii. And we saw as much as 50% coral loss in certain areas, including Keauhou Bay. So at the end of the day, what we found from our analysis is that probably most of the declines in coral cover probably came from these bleaching events. But we did say that probably the amount of sediment in the system wasn't helping either. And recommendations were that moving forward, reducing the amount of loose sediment in the system may help to improve both the water quality as well as the resilience of the coral reefs here. And one way to do that would be by using natural sediment traps or vegetative berms and native plants. All right, so on to part 2 of my master's internship with DAR. So the West Hawaii Biodiversity Expedition was a research cruise led by NOAA in April of this past year. And I was was incredibly fortunate to be able to go on this research cruise and participate as a member of the environmental DNA team. This was a really special project. And really quick, we're going to show a video of the Oscar SETI, which is the ship that we were on. Also, big props to my good buddy Alex Spangler for providing this awesome drone footage. We'll watch a few more of his videos later on. But you get the sense that this is not a small operation. We had something like about 25 scientists as well as 25 supporting crew on the Oscar SETI. And this was a 13-day intensive cruise looking at biodiversity up and down the west coast of Hawaii Island. So there were 3 major collaborators in this effort, which is pretty unique. Usually these cruises, even though they're led by NOAA, will maybe take a small contingent of scientists who are trying to investigate their own research, right? But NOAA will be the main authority there and will be conducting research which guides and designs kind of how the cruise is going to be conducted and exactly where they're going and when and for how long. In this case, this was actually a collaborative partnership between 3 entities. And so this was a collaboration between the Division of Aquatic Resources, and they were doing visual fish surveys that we'll talk a lot more about later. Also between the National Oceanic and Atmospheric Administration, or NOAA, doing eDNA surveys or environmental DNA surveys that I was a part of. And then lastly, by the Hilo Mega Lab that was doing photogrammetry and 3D benthic modeling. And the thing that was really special about this collaboration was that instead of these 3 different methods being applied kind of piecemeal or to different areas, these were used across the same sites. And so what this did is it allowed for an ecosystem-wide snapshot of biodiversity along the Kona coast of Hawaii at a scale that has never been done in Hawaii and rarely, if ever, been done even around the world. So again, better lucky than smart. I sort of stumbled backwards into being a part of this really amazing collaboration and was so fortunate to do so. So really quick, again, I was part of the eDNA or environmental DNA team, and I just want to tell us what eDNA is because a lot of us probably don't know. So environmental DNA is DNA that's passively left behind by organisms in the environment. So what's unique about this is most DNA sampling, you're actually going out, and for fish, for example, you might do a fin clipping where you take off part of the fin, and that way you know that you're sampling this particular organism that's, say, a clownfish or some other reef species. With eDNA, you're taking something like a water sample in our case, or maybe a soil sample, and you are using high throughput sequencing in order to detect trace amounts of DNA. And really, you're kind of looking at more of like a shotgun approach to just seeing everything that is there in that ecosystem. And one thing that's really cool about this is that you know it's there because eDNA, especially in water, degrades really fast within about 24 hours. So it's especially useful when you're looking for organisms that are cryptic or hard to find and may not show up in visual surveys, as well as just rare organisms that are easy to miss as well. So this is a really powerful new tool that's coming online right now. So this is a video that's kind of awesome. This is showing what our kind of day-to-day looked like doing eDNA work and sample processing. So this is the wet lab downstairs. We actually had 2 labs that we were doing this simultaneously in every day. And this is about 2 hours or an hour and a half compressed down to about 30 seconds. And so we would get the water samples, we'd have to keep them cold. They'd be delivered from the boats after the first run in the morning of them going out to sample for us. And then we would typically do 4 sampling runs a day, again, of about an hour and a half or 2 hours apiece. Then there would be a period of cleanup, and they would be just kind of back to back to back. So this was a really intense, but also just an amazing experience to be a part of. So The expedition lasted for 13 days. And this is every day. There's no day off. It's not like, oh, Sunday we're going to put our feet up, right? Every day is usually about 12 to 14 hours. I know that was the case personally for the eDNA team, but honestly, that was the case for everybody on this cruise. It was a monumental effort, and it was really inspiring to see how hard everybody there was working to make this collaboration happen, and to get as much data as we possibly could in this time frame. So we filtered more than 500 gallons of seawater. For reference, off the top of my head, I think it's like 3 or 4 gallons is the average in most environmental DNA studies. So again, this is a really, really large scale effort. We're not just looking at, one little area of Hawaii. We're looking up and down the coast at more than 80 sites for the eDNA analysis. And I think they did something like 110 or 115 sites for the visual surveys and that 3D benthic modeling. I also got to spend one day in the field diving and collecting water samples, which was super fun. And even though it was intense, it was also just a hell of a lot of fun. I went from, knowing these people not at all, to feeling like these will be lifelong friends and people that I will forever be happy to run into as I move through my career in the future. One last Alex Spangler special here. This is just one of our boats taken off. So we actually had 3 different boats that were launched for the 3 different crews. And again, they were at this all day, every day, in and out of the water. And then the eDNA crew would bring samples back to us 3 or 4 times a day, which we were kind of processing in real time. So usually would be up at around 6:30, eat a quick breakfast, and then starting about 7 a.m., 7:30, would hit the ground running, and we'd then usually fall back to bed, delirious at about 9:30 or 10 p.m. at night. So the last and sort of I feel like the capstone of my internship experience was getting dive training and learning the survey methods that I needed to actually get in the field and to really be a part of marine conservation and coral resilience and conservation efforts here in Hawaii. And this is broken into the initial dives and certifications that I needed to get comfortable in the water, scientific diver, and a slew of certifications that I needed to really take it to that next level so I could collect data underwater. And then finally learning the survey methods as well as fish identification and sizing was kind of the final piece of the puzzle to get me into the field with DAR. So the initial dives and certifications actually started before my internship and turned out to kind of be maybe the impetus for me really embracing marine systems and knowing that I wanted to work on coral reefs for the rest of my life. And getting my feet wet for the first time, I had never done any scuba diving in my life. I'd grown up along the ocean. I've spent a lot of time in the water. I'd done a fair amount of snorkeling, a lot of body surfing. I love the water, but when I got out here, it seemed obvious that I needed to go experience the reefs, and what better way to do that than by scuba diving. And on one of my very first dives, I can tell you the moment that I knew I needed to be in the water for the rest of my life. And that was actually involving this little handsome guy on your left here, which is Dacilus albicella, which is a small, very territorial fish that's endemic to Hawaii. We have only out here. Really beautiful. And so usually you'll see them schooling, maybe 5 to 15 fish around the coral that is their home. And so what's really fun too is if you get too close, they're not scared of you. They're actually very protective of their territories, and they make a cute little chirping sound when you're getting too close to them. And so I remember watching sort of a cloud of these beautiful fish underwater on one of the first dives I ever went on, and I was fascinated by watching this behavior where I started watching one of these fish start almost vibrating its body against the coral that it lived on. And it kept repeating this behavior over and over again, almost like a dance. And I was mesmerized. It was just so beautiful. And it should have been obvious to me, but it really wasn't until this moment that I could just stay and watch this cool thing happen underwater. And from then on, I was sold. I was like, I am in on coral reefs. I'm in on diving. This is what I want to be doing. And so this is really actually what led me to kind of really know that I wanted to work in marine systems and eventually to begin my internship with DAR. So I got my open water certification, my enriched air certification, sort of basic level certs. And then as I began my internship, my mentor, Chris, told me, you got to get about 40 dives to really feel comfortable in the water before you can progress. So I continued doing that through spring and summer of last year, at which point I jumped into the scientific diver course. So this is a 3-week super intensive course that actually some of my dear friends out here are just beginning right now this week. So Godspeed and good luck. It's the first week is savage, but I promise by the second and third week, it all comes together and it's going to be super fun. So the scientific diver is a pretty high level certification, again, very intensive, and is what's used by NOAA, as well as other agencies across the world, as the primary qualifier for being able to collect data underwater. So along with my scientific diver, I've now achieved my 100-foot depth authorization, which is an additional 18 dives, gotten my NAUI Master Scuba Diver certification, my NAUI First Aid and Professional Diver cert, Rescue Diver, American Red Cross, First Aid, CPR certification, these other things. And then across the back of the screen, you can actually see this is part of my master dive log. So in the past year and a half, I've logged more than 100 dives, which includes more than 70 scientific dives. So I am certainly not the most experienced person in the room here. I know many people, including some of my program, with thousands of dives, but I am still really proud of how far I've come. And I've worked really hard to develop sort of a sense of comfort and experience in the water here. So this single slide actually represents a large amount of time and effort, despite appearances. So for survey training, there's kind of 3 major portions of this. The first of which is you just got to learn your fish out here in Hawaii. And so learning to identify fish and a handful of invertebrate species that we are tracking in monitoring efforts for DAR is quite an undertaking. And it's still absolutely something that I'm in the process of learning. And I learn probably at least 1 or 2 new fish each time I go out. And I am constantly blown away by just the deep, profound level of knowledge by my peers and by other people at Darkona, where I'm on the boat and they're just rattling off scientific names where I go, what is that fish again? Can you repeat that? But I am also proud of how far I've come as well. Sizing is actually also really difficult. It takes a lot of practice to get good and accurate sizing. And this is important because you not only have to identify the fish, but you need to figure out how big it is. Because one of the most important metrics that we're looking at is not only diversity or measuring the number of different species we're seeing on the reef and how many individuals we're seeing, but we're also tracking the the total amount of fish and how much they essentially weigh. It's like their metric weight, right? And so these metrics are a really fundamental way to track how healthy a reef is. And again, the more biodiversity you see, the more fish you see, the healthier the reef is. So the next part of this is methods and protocols. So there are 2 primary monitoring efforts that are still being used by DAR right now. And the first one of those is the West Hawaii Aquarium Project. This is a monitoring effort that's been going for more than 20 years. It's across 25 permanent sites up and down the Kona coast of Hawaii. And this is a really long-term data set. So this has its own set of equipment that we use, and uses 4 surveyors following these transects. It's it has kind of its own rigmarole, and then a separate different method and protocol is for the fish and habitat utilization surveys. And these are actually a new addition for DAR. And the first actually kind of experimental try at this was during the West Hawaii Biodiversity Expedition. One of the really cool things about getting to do the fish and habitat utilization surveys too is they're just being put into place. So some of the sites, about 50 every year, are random and will never be repeated. And then there's also going to be a large number of permanent sites. But these permanent sites are just being put into place by DAR. And so it's been a really amazing experience to get out in the field and to get to these sites. And because they're randomized, many of these are places that few, if any, divers really have ever been before. So that's been kind of a special experience. Then sort of the last step of this is putting it all together, putting it into practice. And so this is actually getting out into the water, using the skills in fish identification, all of the skills I've developed and cultivated in diving and, getting my comfort level in the water to where it needs to be, and actually putting it onto a data sheet. And so this was done doing solo snorkel practice at Richardson's Beach Park, going the mornings before work, also getting over to Kona side with DAR to do KA retro surveys, which is an old survey that DAR has been continuing for the last few years here, as well as sizing practice with the Marine Option Program, and doing a few rounds of the West Hawaii Aquarium Project surveys before finally getting into the field. So field work at last, this is really the capstone. And the last large block of my internship hours, I was so fortunate and so excited to finally get out and contribute and be a part of these field surveys with DAR. So again, these are fish surveys and also doing some benthic modeling. So essentially doing that 3D photogrammetry stuff that the Mega Lab does, and generating real data that I'm contributing to that is being used to monitor the health of coral reef communities here and guide future management decisions here in Hawaii. And again, this has just been such an awesome way to finish my internship, and it's been really deeply gratifying. It's also been really excellent to kind of feel like I finally got to move out of the pandemic and into what feels like the real world again. So yeah, super amazing experience. So looking ahead, I am excited to continue to dive on a volunteer basis with DAR. And I'm currently looking for a full-time position in coral conservation and marine management. And I am excited to see where that journey takes me. So thank you all so much for being here. I want to acknowledge and give a big mahalo to my friends, my peers in my cohort, my professors in the TCBES program. I want to thank my amazing family who has kept me laughing and encouraged the whole time. I would not have made it without you. I want to thank my mentor, Chris Teague, for answering my random questions at all hours and giving all kinds of sage advice. The amazing people at Darkona, and I want to give a particular shout out to Ashley Pugh, who without which I never would have made it into field surveys and been at least as competent as I have become so far. I want to thank all my fellow officers and members of the Kaiameaola Club and for just making that such an amazing experience. I will always cherish you guys and consider you some of my closest friends. And I want to give the biggest and most profound mahalo that I possibly can to my advisor, Lisa Canali, who is truly one of the most hardworking and open-hearted, lovely humans that I have ever had the good fortune to meet. She truly is inspiring every day, and I cannot thank her enough. I'm so happy to have known her. Yeah, so anyway, thank you guys so much. I also want to give a quick shout out to my sweet houndish boy pictured here, Finn, who's tagged along with me to Hawaii and has continued to be my rock, my foundational moral support, guiding me along this journey. So yeah, guys, any questions you have, let's get to it.